Hi all, I hope you're all staying safe and dry on this crazy weather Sunday, or I don't know, whenever you're watching this later. Let's hope that I can get through this video without my phone giving me another Amber Alert about the weather. All right, so I wanted to do probably just like 2 little videos that cover a couple of the topics we haven't seen yet for projects 4 and 5. If you have a different issue you'd like me to cover, shoot me an email, let me know, and I will try and whip something up on that. Hopefully talk about this. We'll talk about this a little bit more tomorrow night. But for now, we're going to talk first about some logical indexing and subsetting. Right, so I made a little baby version of what you are supposed to have for your project 4. Remember, in project 4, you're going to have 52 of these because there's 52 cards. In this case, I'm just doing 1, 2, 3, 4, 5 with some random sporadic color suits and, well, I mean, obviously the name matches the rank. And then I turned that into a data frame. All right, so when I say logical indexing, what do I mean? Actually, it's not even really indexing. I guess I should. The idea is taking these logical things and applying them to what we've got, right? So rank greater than 2, right? What does that give me? False, false, true, 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 right? That is, these are indexes of this guy, right, where this statement is true, right? So for each element of this vector, it looks, okay, well, is this greater than 2? No, false. Is this greater than 2? No, false. Is this greater than 2? Yes, true, right? So you can do this with all sorts of different objects. You can say, equals to 3. You can say color equals to red. You can say rank divisible by 2, right? Whereas, I mean, divisible by 2 meaning, this is mod 2, so the remainder 2. So then you would, if you wanted to say divisible by 2, this equals 0, right? The remainder with respect to 2 equals 0 when it's even. So that's what I'm asking you to do with all of these different guys. I figured I would show you how to use the subset function, right? Subset, return subsets of vectors, matrices, or data frames which meet conditions, right? What have I been doing up here except conditions, right? That's what I'm saying. I'm saying conditions. I want to make B as the subset of cards where what is true, where color equals black, right? So B is a data frame that is a subset of cards where color is black. That's all I'm doing, right? And later on, you would need number of rows of B, right? Number of rows of B divided by number of rows cards is 0.6. And indeed, 60% of my cards are black, right? So if I wanted to do the set of diamond cards, you would do what? I would say D, the subset of cards where suit. I'll go ahead and do one more. Diamond and spade cards. I don't think I asked you to do this, but I'm going to make this up, right? So now I have this new command in, right? So what I'm going to say is I'm going to give this a vector. And what this logical check is going to check for suit that is in this vector, right? So either this or this, right? So now, oh, it helps if you spell spade right. If you say space, it will check for diamond and space, and then you will only get the one diamond, right? So now D is these 4, 1, 3, 4, 5 that were our 4 cards that were diamonds and spades, right? And we actually already talked about the mod command too, but we can, right? Even is the subset of cards where rank mod, ooh, man, the spelling is not good today. Rank mod 2 equals 0. Right. And 2 and 4 are now in our even one. Right. So that is how you kind of will make all of these subsets that I'm asking you to make. I'm going to ask you to kind of combine them in different ways and do different stuff with them. Hopefully you can kind of follow the bouncing ball of what's going on in that help. But again, if you can't, let me know. If there's anything specific I can clear up. You are going to have to remember your formula for conditional probability. You're going to have to remember the difference between union and intersect, and how to compute those probabilities. Have fun playing with these cards.